run .NET applications on Linux, either directly or within containers, and need to be able to diagnose them? If so, this session is for you. I'm Sam Spencer. I'm on the .NET team, and I'm here with Mark Downie from Visual Studio, and we're going to talk about diagnostic techniques for .NET running on Linux and within containers. Before I delve into the details on the tools, I want to step back a little bit and talk about the diagnostic landscape. There are a couple of different techniques you can use when diagnosing an application on Linux. The first one you should be aware of is the console logs. So .NET has infrastructure called iLogger for writing log statements. ASP.NET includes that automatically and will emit a set of logs to the console. With iLogger, you can control the verbosity of the logs through configuration with app settings or environment variables. The next level up from that is OpenTelemetry, which extends the logs with distributed tracing and metrics. OpenTelemetry has an exporter model, so you can send your data to different APMs, such as Azure Monitor. If you're using Aspire, OpenTelemetry is included automatically, or you can add the NuGet packages and reference it with a couple lines of code. Visual Studio supports remote debugging for both VS and VS Code using an agent. Typically, that's not used in production, A, for connectivity reasons, and B, because once you're broken in the debugger, the application is paused for everyone, which will affect the production use of that app. What I'm going to talk about in this talk today is a series of tools, the .NET-star tools, which is a set of diagnostic command line tools that you can use to collect artifacts and either analyze the results directly on Linux or bring them back and analyze in Visual Studio. If you're like many developers working on Windows and developing Linux apps, then hopefully you're familiar with WSL and Docker. Both provide a enhanced development environment for creating Linux apps while working on Windows. WSL is not just running a Hyper-V on Windows. There's actually a lot of kernel integration that makes it easier to access the Linux subsystem from Windows. Working with either, you can F5 and deploy directly from Visual Studio or Visual Studio Code. If using WSL, then we have bidirectional file system mounts. So the Linux file system is mounted into Windows via UNC path, and the Windows file system is mounted into a Linux system automatically. If you open or run an application on the Linux side that listens to a port, then you'll get automatic port mapping over to Windows for WSL host. So this is how, when running an ASP.NET app, let's say listening on port 5000 or 5001, that you can access that via Windows directly via that same port number, even though technically it's running under a different IP in WSL. Last little tip is you can now run Windows commands directly from the Linux shell, such as Notepad. You can do notepad.exe. You have to include the exe part. And then it will map the file system across and use line feed endings. So you can edit your config files in Notepad rather than needing to rely on VI or Nano. With Docker, both Visual Studio and Visual Studio Code have a great integration experience to run and launch your apps under debugger. So what I'm going to spend most of my time in this session talking about is the .NET-star tools. So this is a set of command line tools for collecting diagnostic artifacts. You can install it if you have the .NET SDK by using the .NET tool install command. You can do that as part of your Docker build if necessary. But beware if you're running that from Visual Studio. Visual Studio by default has a fast node that only runs the first stage of the Docker build. You can turn that off with the flag shown here in your project file. Alternatively, and what's probably more useful, is you can dynamically get the tools. We've made them available via URL redirect. So you can just wget those tools directly, chmod them, and execute them. So this makes it easy with an SSH session to go collect the diagnostic artifacts. Some of these tools allow you to analyze in place, but as Mark will show, we have a much better experience to be able to bring those back to Visual Studio and get deeper analysis. The first tool I want to talk about is .NET Counters. This is an interactive tool that displays metrics from your .NET app. These are based on both Event Counter and the more modern System Diagnostics.𝗦𝗲𝗀 API. This should be your first step in diagnosing and understanding performance issues. So for instance, you could look at what the CPU usage is, if you have exceptions, what the exception count is, GC stats such as the heap size, size of the last collection, and a bunch of ASP.NET and HTTP client metrics as well. Let's take a look at this in action. So what I have here is a sample application we use for diagnostic tests, or these diagnostic demo scenarios. It's an ASP.NET Core application with MVC and a series of tests. So I'm going to run this inside WSL. And while that starts up, I will open up a new Ubuntu session. Within this, I'm going to go to my home, and I'm going to do a ps-ef to list the processes. And what we should see here is our application, our buggy demo, and that is running under .NET. And we'll see Visual Studio is actually using the file system mounts from Linux over to Windows. So this is using running the buggy demo code directly from my C drive. This is easier for Visual Studio to build it locally and then map it over here to run it. If I run this app, we'll see very quickly it does some file I/O and gives a response there. So what I can now do is I'm going to run the .NET Counters app. That gives our process ID. So we can do the same. We're going to do a monitor. We're going to give it that process ID. And then we're going to tell it which counters we want to watch. And so that is going to be system.runtime and Microsoft.ASP.NET Core.hosting. If I get that right, what we now get in this cute little command line tool is a live view of the counters for my application. If I come here, run high CPU for a second, it's now gone and made a web request. So that counter is fired and is being caught by the counter. So this is actually tracking two different types of counters in my application. We have system.runtime, which is a classic event source event counter. And then Microsoft ASP.NET Hosting is a system diagnostics metric meter, and it has a series of meters. We've got one which is active server requests. This is a point value. And then we've got request server duration. That is a histogram value. Now these have dimensions to them, so you can see what the method is, the scheme, and basically all these get mapped out into columns. If I start another instance of Ubuntu, and I'll drag this one off, and what I can do is /load test. I have a little shell script that is making a series of curl requests to the server to go fetch the value. So as we're doing that, we're seeing the number of active requests is going up and down as those requests are processed and completed. We've got how long it's taking to handle each of those requests. We've got our CPU usage is tracking about 36%. We're doing some GC fragmentation going on. We can get all these stats from our running process directly using .NET counters. If I stop this, we'll see those numbers track back down to 0. Our CPU usage has gone back down to 0, etc. Showing some other quick useful things. One of the nice things about WSL is I can now actually run Windows commands directly from the Unix environment. So if I do my load test.sh, I can open that in Notepad. It's on a different screen. I'll bring that across. And what you can see here is that is Notepad being run from our WSL environment. It's using Unix line fitted endings. And that file, if I save as, we'll see that is going from the Windows mapping into Ubuntu. So WSL localhost, that's how Windows maps into the WSL file system and to my home directory in the Unix environment. So there's a couple of useful little tools using WSL on Windows to test my Linux application. The next tool I want to talk about is .NET Trace. This is a tool similar to ETW, which you may be familiar with for Windows, for collecting event activity from the .NET runtime. The .NET runtime itself and libraries can emit events, and those can be collected via a mechanism known as event pipe through to .NET Trace. When you run .NET Trace, you can either give it a profile, which is a standard set of things to collect, or you can give it a list of providers, the events for those providers, and keywords for what is to be collected. Typically, this is used for collecting CPU information, but you can collect GC info and a bunch of other deep, gnarly runtime information as well. The trace files can be analyzed on Windows with either Visual Studio or Purview, or if you want, you can convert them to Speedscope, which is a web app, or Chromium, which uses the F12 tools in your browser to analyze those files. Let's take a look at using .NET Trace in practice. So for the next scenario, I'm going to use the same application. It's still running from before, except now we're going to collect a trace. So we'll do .NET Trace PS, list of processes, should be the same as before. We can now do a collect, pass in that ID, and say we want to output to a file called trace, and we'll give it the format. And this is where we can do it in NetTrace, we can do it in Speedscope, or what I'm going to use here is Chromium. That's now recording. I can go over to my other window, start my load test. This is going to generate something for us to actually look at. And then I can go across here and stop the recording. So we now have a Chromium JSON file. I'm actually using Edge here rather than Chromium, but it's based on the same backend. So I can do Edge tracing or Chromium tracing. I want to load. We're already mapped over to the same file. Same place, and I can load a trace.chromium.json. So this is now showing me, here's my single process, here's all the threads that are going on in that, and then what we're getting here is a flame graph for each of those threads. And someone had a gaming mentality when they designed the keyboard shortcuts for this, because it uses WSAD to like navigate around in here. And what we can now see if we zoom in enough, that here we're running our buggy demo code, process big file, and legacy service process. I can zoom in, process big data file. So I can zoom in here and see exactly how much time is being used by each of these pieces, getting the data in Chromium format. Mark will show this same scenario analyzing our trace file in Visual Studio.
So Sam's been showing off how to do this from the command line, but I'm more of an IDE kind of person. I like something to click and point at. So I kind of like tools to kind of analyze this kind of stuff within the IDE. The advantages, of course, of using an IDE is the fact that you're kind of probably familiar with most of the views already. So if I was to follow up now with what Sam was doing from the command line and now look at this within the Visual Studio IDE, here's a couple of traces I've already collected, and actually a few memory dumps that we'll look at a little bit later. So I can simply drag and drop these net trace files. These are cross-platform. They are available. You can produce them on Linux environments and simply open them up on a Windows machine with Visual Studio. So I've done a simple drag and drop, and the profiler here is kind of converted that, and you see immediately you have kind of if you've done any profiling in Visual Studio, this is a familiar look. You have your graphs up at top. You are looking at a 30-second trace. The session count is right there. We are looking at this over a period of time here. And down the bottom are the providers, the standard providers that come with a trace, and that was been collected. And you can see there has been some movement of CPU over time. You can see where I've collected events over this time frame. What I can do here then is start to see if there's any kind of causal relationships I can see over time. So I'm going to select the request rate, how quickly I was asking for items, and that pulls up this particular graph here. You can see that in almost a sawtooth looking shape. I'm going to go to the system runtime and see if there's any other metrics that I might want to look at in this context. And I also, because in this particular issue, I was looking at a process throughput issue. I'm always very interested in things like thread pool queue length and things like thread pool thread count. And if we look at all of those three things together, what we see here is as the rate increases, you see things like the thread pool length increasing to make up for that increasing rate, and the thread count kind of going up to match that. This is the kind of thing you get to see with the IDE. It's kind of looking at this really big picture view of what happened with that trace and see if you can use that to kind of come to some kind of hypothesis. The other areas here, in addition to counters, is CPU usage. The CPU usage kind of shows me exactly by sampling where we spent the most time. So if I were to, for example, look at this function here, it doesn't look like it's my code, but it might lead me to kind of a better understanding of what was going on. So I'm going to go ahead and click that frame. And that brings up typically the function view. I'm going to switch just for a moment to the flame graph view, because that's kind of matches what Sam would have been looking at within the web, looking at a kind of a flame graph. You can actually flip the flame graph so it looks more typical. That's, again, just the same type of views, but you're now looking at it. What I really look like is the fact that we can look at it from the code standpoint. So I'm actually going to start looking in this function list for anything that looks like has a namespace that I would recognize. I don't quite see one yet. Let me see if I can scroll through, see if I can find something interesting to look at. Not many interesting ones there. Let me open another trace file, because I think what you can really get done with looking at these trace files is get a sense of what your app was doing and what your particular code base was doing. So I'm going to have a look at this. Let's have a look at this, for example, and see if we can find any of my code namespaces. I should be able to find one, I'm hoping. Here we go. Okay, Buggy Demo Web. This is kind of code we've been looking at. What's interesting now is that I'm looking at the code here, and actually, just to kind of put a little bit of, we've been working with Copilot recently. We can actually analyze methods, so I can actually ask questions about this high piece of code, the piece of code that seems to be there a lot. What Copilot seems to be telling me is that my use of .result here is problematic in that it looks like it leads to deadlocks and efficient usage of threads. Essentially what that means is that when I use this .result, I am throwing a thread pool thread at that, and then I'm throwing another one at it. So in essence, what is happening is that my app is using too many thread pool threads. So if you saw that kind of sawtooth action where I am queuing up these requests, it's because I'm running out of thread pool threads. This kind of anti-pattern is a problem. And it's really difficult to get that kind of information from blogs alone. So you have to really start by thinking about traces and then trying to map that back in a visual way. And then mapping that back to code kind of helps you form these hypotheses.
So the next section I want to talk about is dumps. Collecting a dump is basically collecting a subset of the process memory structure. We can do this manually with the .NET dump command, or we can collect automatically after a crash using a set of environment variables. We typically want to use .NET dump command rather than the OS capability for collecting this, because the OS isn't going to pick up the right memory structures to handle the JIT translation of IL to native code. You'll just get the native blocks, and so you won't be able to map that back well to the code that you did. The types of dump that we can collect contain different levels of information. So the mini dump and triage dump are essentially the same, and they include basically the stack frame, modules, enough information to be able to figure out why a crash occurred. The difference between them is that the triage dump will have PII in those data removed where we can, so it's more suitable for a triage process. The heap dump adds the rest of the memory that isn't memory map files for modules. And then a full dump will include all the memory for your for your dump. We can analyze dumps either with Visual Studio or a tool known as SOS. This doesn't stand for the international distress symbol. It actually stands for Son of Strike, which is an esoteric internal naming thing. There was a tool called Lightning, and then another one called Strike, and then we developed the Son of Strike, and that got summarized to SOS. Anyway, it's the tool that you can use to analyze a dump, either using WinDBG or integrated into the .NET dump command itself. Collecting dumps on Linux can have some problems. It requires capability of ptrace, which is a system capability. And particularly if you're running in containers, you need a kernel version greater than equal to 4.8, or you need to add the capsys ptrace capability to your container to be able to go collect them. The other thing to be aware of is where your dump is collected to. Typically in a Kubernetes and other environments, the tempter is mapped to the tempfs file system, which basically uses a RAM drive. That comes out of your application memory quota. So if you're trying to debug something that is running out of memory and you start writing a dump to tempfs, which is also coming out of your memory, you're going to run out of memory even faster, likelihood crashing, getting an killed for your container, so you'll lose all the data. So be aware of that, of when you're collecting dumps, where you collect it to. So I'm going to transition now and do a demo of .NET Trace and SOS. So for this next demo, we have the same buggy demo code application. I will start the load test against it, and we will collect a dump. First of all, I'm going to call PS to get the list of processes. Ours is buggy demo web, so that's 794. We want a full dump to collect. We want a full dump, and we'll write it. I think that's actually type. There we go. So we have now collected our dump. We can now do .NET dump analyze. American spelling. I'll stop that over there, and we make this full screen. So we're now running SOS commands. So if we do help, we can see we have a full list of SOS commands available to us. So let's go through a couple of the interesting ones. Because we've got all the memory, we can go through the heap and the stack. So we can do dump heap -stat. And this gives us a dumping of all .NET objects that were part of the heap. So for instance, in this case, we had 4,993 strings taking up 361K. We can look at our call stacks and our threads. So we can do CLR threads, all the threads available. We can then look at what's happening on an individual thread. So for instance, 333 here is one of our thread pool workers. So we can do set thread -t ox333. And then we can do CLR stack. And that will give us the full call stack for that, including the code files if it has the mappings to the PDB. There's a lot of parameters we can do on CLR stack to get more details. The final one I want to show is dump async. And we're going to call coalesce. What this does is this gives a view of all the async call stacks that are in execution. But because there can be many more async call stacks than threads, what the coalesce commands does is says where there are more than one duplicate call stacks, rather than displaying each of them individually, just display them once and give me a counter. So for instance, stacks 4 here that's occurring, which is HTTP2 connection handling in Kestrel. There were 5 instances of that call stack. So it just reduces the amount of the volume of information. So there's a lot of commands that you can do with SOS. It is very geeky, somewhat esoteric, but very powerful and can get you the information you need in a pinch if you have to do analysis through SSH, whatever. The better experience, however, is to copy the file locally and analyze it with Visual Studio. And Mark will show that in a second.
Okay, so I'm going to continue to make the case for Visual Studio as the dump analysis starting point. Again, I love IDEs. I love point and click options. And so I'm going to make the case here that when you start to think about dump analysis, especially if you've spent a lot of time in the IDE already, there's some great tools that you've probably already used that you can use for dump analysis. And I'm going to kick off by looking at the analysis from the perspective of a heap analysis. All right, so same as we did earlier, I've got a bunch of artifacts I've collected. In fact, I collected all of these from App Services for Linux. I'm going to start with the first memory dump. This is a memory issue I'm trying to track down. You'll notice there's no extension here, doesn't need one. Dragging and dropping into Visual Studio recognizes it immediately as a Linux dump. How do we know it's a Linux dump? How do you know I'm not tricking you at the moment? If we do a .so, you will see here that we have these shared objects that are kind of fundamental to Linux environment. So this really is a memory dump we've collected from Linux environment. Again, because we've done all the work for you with the DAC, this was kind of a problem in the past where it was kind of difficult to do this kind of analysis because you'd need to match DAC versions and a whole bunch of stuff. We take care of all that for you. Just bring it to Visual Studio. We know exactly what to do. Okay, so this is your opening file summary page. Okay, and on the right are all the actions you can take. A memory dump, as kind of been described already, is a way in which we have frozen a single moment in time. And the reason why you might want to bring that back to Visual Studio is because you do that all the time, typically in Visual Studio already. When you have a breakpoint, you have essentially paused your IDE, you paused your debugging at a moment in time, and all the tools you can use during debugging, you can mostly use them while you are doing dump debugging too. And on the right here, we have a bunch of the actions you can do. Because this is a memory issue specifically, I'm going to start with debug managed memory. We could start this with debug with managed only. That would essentially start this up, and you'd see essentially my breakpoint. But because I know it's a memory issue, I'm going to start with debug managed memory. And that will start to initialize the memory tool. And the memory tool here is kind of pulling all the stuff together. And here we have some options in this memory tool. You'll see that I have elected to show just my code. I'm going to actually take off these options. I can look at objects from specific generations here. I have got all generations, but I could do Gen 1, 0, or 2. I can also look at the large object, heap pinned object, and so on and so forth. But in addition to that, I can reflect on this to show just my code, which limits the list because it's looking for the objects that were incepted from my particular code base. And then also, because again, this is a memory issue, I'm going to collapse all of the small object types as well. And that will be this option right here. And so you can see I've got something called data record. Don't necessarily know what that is, but it's something that I know is now something that is going to be valuable for me to look at. When I actually select the objects, you can see down the bottom, I have a kind of a graph here showing me where this is linked to. It's actually a static variable here that is essentially a list that has a bunch of these data records in a list. So I've got what looks like, from an initial look, it seems like I've got a static list that's just never going away, and that might be the reason for my issue here. What I can do with Visual Studio that is really, really helpful is I can take two memory dumps and compare them. So if I were to have taken a dump earlier than this one, I could compare it to that baseline and understand where my growth is happening. So I'm going to go ahead, and in this top right corner here, you'll see I can compare with the baseline. So I'm going to select and browse to the next memory dump, which actually was the first one. So imagine I've taken two memory dumps because I've seen growth over time, over maybe a 24-hour period, and I want to compare where I've started from to the growth I've seen. And in a very visual way, Visual Studio is kind of showing me, hey, I'm seeing an increase in your data records of 508. I'm seeing an increase in size of about 108 meg. So I now have a better sense of where all that growth is going from. And that's really easy with Visual Studio. That kind of analysis over your tools is quick ways to kind of point and click and say, actually, I'm only interested in my code. I'm only interested, for example, in the dead objects, or I want to show dead objects. I'm only interested in a particular generation. Visual Studio is a point and click away. Now, the ardent WinDBG fans will be telling you I can do that too, and that is very true. But if you've been using Visual Studio to develop your application, it's really just a great place to start if you're thinking about how I can get to these insights. And in talking about insights, we actually also have a tab of insights where you can kind of get a sense of some of the common problems that we have, and you can kind of look for things like duplicate strings, sparse arrays, or event handle leaks. And we kind of help you with that kind of analysis. Want to just kind of look at a couple of other different types of dumps that I've collected here that might be interesting to kind of do a bit of analysis on. I'm going to drag and drop another dump number 2 here. And the reason why I'm interested in this is because that memory isn't the only other type of analysis you can do with dumps. In fact, you could have done that kind of analysis with a GC dump, which would have probably been a little, probably taken a little less effort to capture. But there are other kinds of analysis because this is a full memory dump I've captured on my Linux box. So I'm going to start by, again, clicking the first action, which is run debug with managed only. And debugging with managed only essentially starts me as if I was debugging the application. The only difference being is that I didn't have a break point on a particular line. Because remember, when you take a memory dump, you're taking it at some particular point in time. You've not necessarily timed it against a line of code. And so you don't necessarily know where you're going to end up. And so in this example, see if we've started. I think we've already started this. Right now, so I've actually started with the parallel stacks window. Again, depending on the type of issue, and the issue that we're looking at here is actually the parallel stacks window is telling me straight away it's a deadlock issue. For those of you who aren't familiar with the parallel stacks window, it is a view of either your tasks or your threads. So for me, what I like to do when I'm dealing with memory issues or threading issues or process throughput issues is look at the very big picture. And thread pool, looking at the thread pool or looking at the threads are a really big picture look. And in fact, what I've seen is a typical deadlock. What we have is we have thread 311, and it says, hey, I'm waiting on a lock that's owned by 343. At the same time, 343 is saying, hey, I'm waiting on a lock owned by 311, right? So you can see that these two threads are simply waiting for each other in a very circular way. What I love about Visual Studio, again, this is something that the other tools can't do as well as Visual Studio, is get you back to code. I'm going to double click on this frame, and you can see now I have what looks like a function here that is double locked, and it looks like it's doing a from account to account. I actually get to look at the because it's a full memory dump, I get to look at the objects themselves. I can look at the from account to account. I am actually right now in thread 343, but I think if we recall, let me go back to parallel stacks. It was 343 deadlocked with 311. I can quickly switch threads, just like I would if I was debugging an app locally. I can switch to 311. Now I'm looking at the code that was running in 311. And you can see here, I've gone from account and I've locked on to account. And where I came from, I was locking on to account first to from account. Essentially, this is what has caused my deadlock. And of course, here I have the opportunity to kind of go through and I can ask Copilot questions again if I want to at this point. But my point here is that we get full fidelity because of either PDBs or decompilation. I get to look at my code, and that's what the powerful thing with Visual Studio really is. Finally, just the last thing I want to show you with dump debugging is you can also run a specific kind of analysis on your memory dumps. Let me pull in my last. In fact, let's continue to look at this memory dump. Let's pull that one back in again. We can actually run analysis against that. That's the final section here is run diagnostics analysis, meaning I can ask Visual Studio to analyze this dump for me. And as you can see right away, without me actually looking in parallel stacks, it's telling me, hey, we've detected that you have a deadlock. And I can actually now start asking Copilot questions about this particular deadlock, and it can analyze the code and the threads that were involved in this particular analysis. And if you've never seen a deadlock, this can be problematic for you. But this is the kind of analysis you can do. You can also run the diagnostics analysis tool, which you can find in debug windows and navigating, debug windows and navigating to the diagnostics analysis. This is also where you go for any of your other tools as well, whether it's parallel stacks or call stacks, you can find them in this window. And anyway, you can run an analysis type on this memory dump. Again, I can check for process responsiveness in here, and here it's found, actually we found, in addition to a deadlock, it's found information about tasks that are blocked, that are called via task wait. It looks like we have some blocking there as well, thread pool, synchronous task blocked issues there. Again, this is stuff you couldn't necessarily do as effectively in WinDBG, especially if you're new to this. So I kind of like Visual Studio as the on-ramp to debugging, especially if you're a .NET developer who's been developing in Visual Studio. So we've talked a lot today about the collection angle of this. Sam has been really focused on command line tools you can use, CLIs you can use to capture artifacts you're interested in, with traces, dumps. One of the ways in which we know folks are using Linux today is in cloud-based scenarios, whether that's App Services Linux, Azure Container Apps, whether it is AKS, Azure Kubernetes. All these scenarios kind of need the same set of tools. And we also, in addition to creating all those CLI tools Sam mentioned, we also created .NET Monitor. .NET Monitor is essentially a way we've thought about simplifying collection when you're in Kubernetes or Azure Container App scenario. And in fact, Azure App Service for Linux right now uses .NET Monitor to help you collect these artifacts that we've all been talking about. When you want to collect traces, when you want to collect dumps, when you want to collect GC dumps, excuse me. And we've also thought about additional types of artifacts, things like stacks and exceptions. And the way that works, on the right-hand side, this kind of this image I have shows a typical container scenario. This would be AKS. I have my application, which is servicing my customers, which is kind of dealing with the load. And we are using the same concepts again for the CLI tools Sam showed. We have event pipe. We have defined a location we know the application is talking to. And .NET Monitor, which is essentially another container sitting alongside as a sidecar your application, it is looking at the health of your application. And sitting here, I'm actually looking at the health of my user application. I'm going to use .NET Monitor to check the health of my application in Azure Kubernetes. I'm going to use it to collect artifacts I might want to analyze, so we can open them up in Visual Studio. We can open them up with any tool we choose, whether it's WinDBG or any other tools we choose, any of the CLI tools we choose. We can open them up, analyze them, and we can kind of use .NET Monitor to sit comfortably within these container-based, cloud-based scenarios. And even though it's Linux, even though it's in your production boundary, you can safely collect that. And I'm going to show you exactly how we do that here in a moment. So I'm sitting here. Again, I have deployed a AKS application, and I am going to use kubectl to port forward over SSH, so I can start actually analyzing this pod I have. In fact, let me go and really quickly, before I run that command, let you see my pods. Here's my pod running. You can see it's up and running. It's been up for a few hours now. And I'm going to go ahead, and what this kubectl command does, what kubectl port forward does, is it says, go ahead and grab port 52323 and forward it to me locally, so that I can run a bunch of commands. And what that essentially does is, because I've deployed this application, and this is my YAML that I deployed it with. I'm going to zoom down here. In my deployment of my app, I deployed 2 containers. The first one is my buggy demo app, the one that we've all been using to show you all the crazy things you can do with .NET if you really, really try. And you'll notice here I have a mounted path called the diagnostics port. And this diagnostics port is essentially where my .NET application is talking to. So it's talking to this socket here. And this is the event pipe, essentially, that .NET Monitor is monitoring. So I've got 2 containers. My app is this one. But then .NET Monitor sits alongside in the sidecar pattern. So it's sitting there, not giving my customers any benefit, but giving me the benefit of being able to monitor the application. And you can see I'm using .NET Monitor. I've pulled it in this container image. And it also is able to look at, being able to look at that diagnostics port, that volume mount. And because they're both talking to that volume mount, I can use .NET Monitor to essentially ask for anything I want to. I'm going to show you how that works in a very practical sense. So I am currently on my desktop. I'm going to send this command over SSH, which is a kubectl port forward, which says I want the port of 52323 to appear like my local 7000 port. And I'll show you what that means. And so over here, I'm going to issue a curl command. and I'm giving it a bit of secret sauce here to make sure it knows it's actually a API token to make sure it knows that I am actually qualified to make this call. And I'm going to make the call to localhost 7000. I'm going to say, show me, .NET Monitor, show me all the .NET applications that are running in that pod. Okay. And it showed me that, hey, this is the GUID, the UID of that particular pod. And it's in fact the default process, which means any commands I run will all run against this particular process. And so there's other things I can do. I can not just do that, but I can do things like I can grab a trace, just like the traces we were looking at earlier. So I'm going to read this through really quickly here. I'm going to say port 7000, this is pointing to .NET Monitor in the cloud. Get a trace for me. This is the API that shows me the trace. And I want you to take a trace for 30 seconds. You can see just over the line. I've kind of crossed over the new line. And I want you to send that output to my local directory here. And I want you to call it buggy demo trace. All right. So that's 30 seconds. It should be making that call right now. As I kind of mentioned, there's a ton of APIs just like this for .NET Monitor. While this is kind of running, let me just kind of show you some of those API surface. We've got things like processes, dumps, GC dumps, traces, logs. We also have things called collection rules. These are kind of triggers where you can say, hey, it's been really slow recently. And when it takes 20 seconds for a request to happen, go ahead and collect a trace for me. As I mentioned, we have other things like stacks and exceptions that you can also collect that might be useful for a problem you're trying to track down. And it looks like my trace is completed. So I'm going to go look at my output here. And again, we've collected that trace. We can do this. There are several other kinds of calls we can make here. One of the things we do love doing is keeping our things we've collected specifically in Azure. So you can call, again, that 7000, call into .NET Monitor, ask for a trace, but this time I've defined an egress provider. And I've said, send it to what I've defined as a blob storage account. And I'm going to go ahead and hit that one. Again, this is going to take a few seconds to run. But that's going to essentially send, rather than send it to me locally, it's going to send that output directly to my Azure Blob Storage. Again, we have tons of options here for .NET Monitor. You can do all of the things that Sam was mentioning with his trace files. Looks like we got a failure there, but you can do all the things you can do with the command line tool Sam mentioned, but it sits comfortably and idiomatically within the cloud. Again, I hope you have fun checking out these tools. We do invite you kind of to check out these .NET tools. Regardless of whether you're on Linux or Windows, we have the tools to help you collect the right data. There's a bunch of tools that allow you to open them and analyze them. Again, my preference is Visual Studio as the way in which, if I've developed apps and used memory tools and used parallel stacks and used call stacks, all those tools are perfectly valid when I kind of bring these deep diagnostics artifacts. We think the very best experience is Visual Studio, but use the tool that makes most sense to you. Again, when using .NET Monitor, please bear in mind that it's kind of all over SSH, so it's really, really secure. I personally do look after the .NET Monitor tool, so there's a survey right down the bottom. If you're using .NET Monitor or want to use .NET Monitor, please kind of fill out the survey, get a hold of us, and we'd be happy to kind of help you and walk you through the tool itself. Thanks very much.